In part A of this example, we need to find the probability that among 611 challenges, the number of overturned calls is exactly 172. We are assuming that the rate of overturned calls is 33%. Let's find NP and NQ to determine whether we can use normal distribution to approximate the binomial distribution. NP is equal to 611 times 0.33, which is equal to 201.63, and Q is equal to 611 times 0.67, which is equal to 409.39. Both are greater than 5, so we can continue with using the normal distribution as an approximation to binomial distribution. The next step is to find the mean and the standard deviation. The mean is equal to NP, which we just found, 201.63. The standard deviation is equal to the square root of NPQ. So that's equal to the square root of 611 times 0.33 times 0.67. And you should get a long decimal, 11.62291272. And now let's draw a picture to visualize what we need to find. So we draw the normal distribution. The mean is 201.63. We're looking for the probability of exactly 172. 172 is to the left of 201.63, but we have to consider the continuity correction. So to the left of 172, we would have 171.5. To the right, we have 172.5. And if we want exactly 172, we actually want that whole continuity correction strip. So if we're using table A2, we need to convert both the 171.5 and the 172.5 to z-scores. So 171.5 minus the mean of 201.63 divided by the standard deviation. Rounding to 2 decimal places, you should end up with negative 2.59. Then we have z is equal to 172.5 minus 201.63 divided by the standard deviation. And that's equal to negative 2.51. So negative 2.51 would have the larger area, so we find that area would be 0.0060. We have to subtract the other area, 0.0048. So in that continuity strip, we have an area of 0.0012. So that's a probability of having exactly 172 overturned calls. Now, if you want to use the calculator instead, then you would not need to do all this stuff with the z-scores. You would find normal, CDF. We're looking for 171.5 to 172.5. The mean is 201.63. Standard deviation 11.6229172. And working that out, you should get 0.0013. So they're very close, whether you use the table or you use your calculator. Now let's compare, or see how that compares with using binomial distribution. If you're using your calculator, we would have binom PDF, since we're looking for exactly 172. Our sample size is 611 Probability of success is 0.33, and again we want exactly 172, and that would give us 0.0013. You do not necessarily need to use binomial distribution unless the directions specifically say that you need to. I just included it in this example since the book also gives the answer for binomial distribution. You might want to review the viewlet for binomial distribution, which is in section 5.3.